Bienvenido a mi canal. So in my last video I uploaded on my channel, I talked about chromatography, and I said that chromatography is a technique that can be used to identify and determine the purity of a compound. Today I'm going to look at a different technique that can also be used to identify and determine the purity of a compound, and that is melting point determination. Melting point determination, MP for short. Now, what is melting point? Melting point of a substance is the temperature at which it changes its state from solid to liquid, which means that we can determine the melting point of a compound that is solid. If it is a liquid, we cannot determine its melting point, but rather we determine the boiling point if the compound is liquid. So now I have here with me an unknown compound. I don't know its name. One of the students worked with it, but he or she forgot to label it. So I'm going to identify this compound by using the melting point determination. That is what I'm going to do. So let me quickly take you through the materials and the chemicals I will need. So this is my unknown sample. This is ethanol lamp or alcohol lamp. It is called alcohol lamp because the liquid in it is ethanol or alcohol. So it is ethanol lamp. I have here with me my mercury thermometer. This is what I will use to record the melting range. Melting range. I have here with me capillary tube. Capillary tube. I have here matches. And when we come here, this is my Richter stand. This is the clamp. This is my hot plate. My hot plate. And the liquid in this beaker is paraffin oil. It is not water. It looks like water, but it is not water. It is paraffin oil. Okay. So now, the melting point I'm going to do is the capillary tube melting point determination. So I'm going to fill my capillary tube with this sample. I'll demonstrate how to do it. Now we have equipment. We have melting point apparatus. This is an equipment that when you fill the capillary tube with your desired sample and you put it in the machine itself will heat up, and when it heats up, it will melt the compound, the unknown compound, and it will record the temperature. Now, if your lab is not having such equipment, this is the method you can use. So this method is for the lab that don't have the equipment or the melting point apparatus. So if you don't have that, you can use this method. So the first thing I'm supposed to do is to heat my paraffin oil. Now, we are using paraffin oil because it has a higher boiling point. So if we dip our sample in the paraffin oil, we will be able to determine the melting point without the paraffin oil boiling. So the sample will melt at its desired temperature before the paraffin oil begins to boil. So that is why we use the paraffin oil. So I'm going to heat it because it takes a longer time for it to heat. So I'm going to on the hot plate. So whilst I continue with the rest of the activity, it will be heating gradually. So I'm going to on the hot plate. There is a thermostat on the hot plate, so I want to hot it at a fixed temperature, and I'm setting it to 150 degrees Celsius. So now I've on the hot plate, and I'll wait for the paraffin oil to heat up before we dip our sample in it. Okay, so now the next step is to divide the capillary tube. Now this is how the capillary tube looks like. My first video on identification of glass rest, I talked about capillary tube. So this is how it looks like. Both ends are open. So this is an OP end, this is an OPM. Now, if we don't close one end and we start filling our sample, it will come out. So we have to seal one end. So I'm going to demonstrate how to seal this. So I have here with me my matches. I'm going to light the lamp. I'm going to light it. Okay. So what I'll do is I'll hold both open ends like this. Then the middle part of the capillary tube, I will send it close to the blue flame of the lamp. So the blue flame of the lamp, that is what I'm taking the capillary tube. So you have to wait for the glass to melt. So as it melts, it will close one end, or it will seal one end. So the tube is melting gradually. It's melting. It's melting gradually. It's melting. Now the best lamp to use is the Bunsen burner, because the Bunsen burner has the blue flame. Yes, but if you don't have the Bunsen burner and you have the ethanol lamp, you can use it. So it is melting. You have to be really patient. It is melting. It is melting. You have to be extra careful so that you don't get yourself burnt. Okay, so it's melting gradually. So I've separated it. So as it melts, one end will seal, but if you check and it's still open, all you have to do is send it to the blue flame for it to melt. So as it melts, it will close one end. So that is how we separate or we seal the capillary tube. Okay, so it's sealed. So this is how we seal it. After that, you put off the flame. Okay, now the next step is I'm going to fill my tube with the unknown sample. I'm going to fill it. So let me demonstrate to you how you are going to fill it. So let me shift these ones at the back here. Okay, so I've already filled one of the capillary tubes with a sample. It's here. You can see that the tube contains some whitish substance. That is my unknown sample, but I want to demonstrate how to fill it. Okay, so you fetch some small amount of the sample. You fetch it here. You can use a petri dish if you have it, but I'm using the back of this book. And you need the case of a big pen or any pen at all. You need the case. So what I'm going to do is that the open part of the capillary tube, remember we have closed one end. So the open part, you dip it in the sample. So let me demonstrate to you how to fill it. So this is how you fill it. So you dip it like this, then you drop it in the case. So as you keep dropping, you see that the sample will settle at the bottom. So if I can bring it a little bit closer, it is going down. So that is how we fill the tube. Now when you are filling and you do this, if you do this for a very long time, the sample will be packed here. So when it is packed here and you are trying to drop it, it will not go down. It will be very difficult. So you just have to do it little by little. So you just dip it about 3 times, then you fill. So the sample is going down. Let me pull the gloss. The sample is gradually going down. So this is how you fill it till you are able to fill about 2/3 of the capillary tube. So let me demonstrate the last time. So you do this, then you drop it here. So this is how we fill the capillary tube with our sample. So you see, it is dropping little by little. It's dropping. Okay, so this is how we fill the capillary tube with our sample, but I've already done that. Yes, I've done it, and I just wanted to demonstrate how to do it. So after doing this, then I'll bring my mercury thermometer out, because I'm going to use the mercury thermometer to record the temperature. So it's very important. Now, how am I going to do it? I'm going to tie the tube, the capillary tube that I've filled with my unknown sample. I'm going to tie it close to the thermometer, the bulb of the thermometer. Then I'll dip it in the paraffin oil. So I will need a rubber band. So I'm going to tie both of them together. So the rubber band, have to fold it about 2 or 3 times. So I'm going to tie the two together. I'm going to tie the two together. You have to be careful so that you don't break the capillary tube, because the tube is very fragile. It's very fragile, so you have to take your time so that you don't break it whilst trying to tie the two together. I need to wear the gloves very well. Pulling it, and I'll continue to tie the two. Okay, it's a bit loose, so let me tie it another. Okay. Alright, so this is how we do it. So the capillary tube is here. It's attached to the bulb. It's attached to the bulb. So this is how we attach the tube with a rubber band. So now my oil has been heating for some time now. So I'm going to clamp this, then drop it into the paraffin oil. Now the rubber band is not supposed to touch the oil, because when it touches the oil it will melt, and when it melts the sample will drop into the paraffin oil and you will not be able to determine its melting point. It means you have to start the process all over again. So when you are doing it, you have to be very careful. So the tip here, they are going to clamp it at the tip here. Now there is a hole here, because the thermometer is very small. When I drop it in the hole, it will fall down. So just the tip here, just the tip, then I'll clamp it, yes, like this. Then I'll release this one. It's getting off, so let me do this way. Let me bring this one down. Okay, so you bring this down. Bring it down like this. Yeah, you can adjust it to any length you want. Okay, so let me bring it, then we tighten it. Alright. Okay, now I can fix my thermometer and the sample. Now the calibrations on the thermometer should face you the person working, because you are going to read the temperature, so it should face you. Okay, so now I can drop it inside the oil and tighten it. Alright, and tighten it. So this is how we do it. You can see that the rubber band is not touching the paraffin oil. As I said earlier, if it touches, the paraffin oil is hot, so when it touches, it can melt the band, and when it melts, the sample will drop into the oil, and we don't want that. It means I have to start the process all over again. I don't want that to happen. So the sample and the bulb of my, let me adjust it well. Okay, so of my thermometer is touching the paraffin oil, so the thermometer is going to record the temperature. Let me turn the calibrations. The calibrations has to face me. All right. So now the range, we have to report the melting point in a range. So the temperature at which the sample in the capillary tube starts to melt, and when it's finished melting, you have to record it. Now somebody will ask me, how will you know if the sample in the tube starts to melt? How will you know? Now when I showed it to you, it was whitish in color. When it begins to melt, you see something like bubbles coming out from the tube. And when everything finished melting, you see that the tube will be colorless. That is how you will know that the sample is melting in the tube. So now we have to wait patiently. As we are waiting, you will be observing the sample in the tube. You have to observe. When you see that the bottom of the capillary tube begins, you see that there is bubbles coming out, like it's turning into colorless. It means that it has started melting. So we record that temperature. And when everything in the tube becomes colorless, then it has finished melting. Then record that temperature also. So your eyes have to be fixed on it. As you are watching the sample in the tube, then you'll be looking at the readings, the calibrations on the thermometer. Yes. So at this point, you can take a lab stool. And sit on it and continue to observe. So this is how we determine the melting point. So yeah, because the paraffin oil is already hot, it is about to melt. So I need to record my temperature. Okay, so I'm checking. It's about to melt from the bottom. So the temperature is 121. So it has begun to melt at a temperature of 121 degrees Celsius. So I have to wait. You know, the paraffin oil was already on. It was heating. So now we will not spend much time melting our sample. So it is melting gradually. Everything is melting. It started from the bottom, so it is climbing. It is climbing gradually. Okay, so it is done. So the final reading is 122. Okay, so 122 degrees Celsius. Yes, so let me off the hot plate. Okay. Then I'll quickly bring this out. Okay. Then I'll remove the rubber band. Have to be careful because the bulb of the thermometer is hot. Okay, so this is our sample. You see that it is clear. You would think that there is nothing in it, but the sample, the unknown sample, has melted. So it is colorless. It's colorless. From the beginning, we saw some whitish something in it when I filled it. But after determining its temperature, it is looking like there is nothing in it. Yes, it has melted, so it is colorless. And it is transparent. You can see through. Yes, it's very hot though. Okay, so now that we know our melting range rather. So when it began to melt, the temperature was 121 degrees Celsius, and when everything melted, it was 122 degrees Celsius. So this is our range. Now, if you want to know if the sample is pure or not, when the sample is pure, the melting range will be narrow. It will be very narrow, and when it contains impurities, the melting range will be broad. Yes. So now that I have this range here, now what I can do is I have to take a phone. Now when you go home, you take a phone and try to Google to find out some of the compounds that has a melting range between 121 degrees Celsius to 122. So if you get that information online, then you can confirm that the compound is this compound based on the melting range. So I'm going to check on my phone. I'm going to check, there are literature values, melting range for most organic compounds. So you have to check on your phone and see. So you have to check on your phone and see which organic compound has the melting range within what I got. Within what I got. Let me open another site and see. Okay, so I have here benzoic acid. Benzoic. What I have here, the range for benzoic acid is 121 degrees Celsius to 126 degrees Celsius. Okay, so when I check online, I got benzoic acid. So from literature, this is what somebody has done, and the result is out. So it is benzoic acid because what I checked online, the melting range for benzoic acid is 121 degrees Celsius to 126. But what I got is 121 degrees Celsius to 122, which means that this compound is benzoic acid, and it is very, very pure because the difference is just 1 degree Celsius. It's highly pure. So this compound is benzoic acid. So I have used melting point determination to identify this compound and to also determine its purity. So the compound is benzoic acid, and it's very, very pure. It's very, very pure because with the difference between the range is 1 degree Celsius. It's very, very pure. So this is how we use the melting point determination to identify a compound and also to determine its purity. At the last video I talked about it was chromatography, but today is melting point determination. So my friends and my viewers, I've come to the end of today's activity. It's quite unfortunate, I have to say goodbye, but I want to say thank you to all my subscribers. I want to thank you so much to my cameraman Lawrence Uhapo Ajiman. Anytime I mention his name, then he'll be smiling. And also to my video directors Efo Felix and Efo Solo, I want to thank them for their support as well. And to my colleagues, today they are not around, that is why I'm doing it alone. I thank them also. And also to my family for supporting me, my friends and my colleagues from school. I want to thank everybody. Please keep on subscribing to my channel. Keep watching the videos I upload on my channel. And I will see you again in my next video. Bye bye.